Let us continue with the meshing tools. Now we have understood how to achieve the hexahedral elements by editing the geometry. This is one of the methods that we've understood to achieve the hexahedral elements. In the future topics that we learn, we will be understanding some more topics with the help of which we can achieve hexahedral elements. Now that we have achieved the elements, we will understand how to check the quality of the elements, because it is very important that to understand whether the elements that we have got are of good quality or not, because if the quality of the elements is good, the results that we will achieve will be much more accurate. So let us understand how to check the quality of elements. So to check the quality of the elements, what we need to do is, once the model is meshed, you will come to the details of the mesh, and in statistics you have some option which is called as mesh metric. In that, the default setting is none, and here if you click on this arrow, you will see there are lots of parameters by which you can check the quality of the elements. So the first option that we will see is element quality. As soon as you click on the element quality, you will see that there is one graph that is achieved. You can see this graph over here, and you can see some settings. So let us understand what does this denote, or what does this indicate to us. The element quality gives us the composite quality of the mesh that ranges from 0 to 1. If the value of 1 indicates that the shape of the element is a perfect cube, and a value of 0 indicates that the element has 0 volume or negative volume. That means the values which are closer to 1 indicate that these are all good quality elements, and the values that are closer to 0 indicates that these are bad quality elements. You can also click on this graph over here, and you can see which are the good quality elements. So all these which are closer to 1 are indicating that these are all good quality elements. But we also have some elements which are closer to 0. We have 0.5, ranging between 0.5 to 0.6. So these are distorting in shape, and they are denoting that they are slightly bad in quality. Okay, so this is what element quality indicates. Then you can also check something for Jacobian ratio. Now in Jacobian ratio, if the value is 1, it represents that it is a perfect shape. But as the Jacobian ratio increases, the shape of the element starts distorting. That means if you have a triangular element, let us say you have all triangular elements, so a perfectly equilateral triangle will have a Jacobian value of 1. But as the Jacobian value increases, for example, if the Jacobian value is 30, the shape would be something like this. If the Jacobian value becomes 1000, the shape becomes something like this. So the shape starts distorting. Similarly, if you have quad elements, so let us say this is a perfectly quad shape, so the Jacobian value will be 1. But as the shape starts distorting, as the Jacobian value increases, let us say this is having a Jacobian ratio of 30. Further, as it increases, let us say this is having a Jacobian ratio of 1000. So the Jacobian ratio is nothing but a shape check, and it indicates according to the values denoted. So the values which are closer to 1, that means it is having a perfect shape. But as the values start increasing, that means the shape is getting distorted, and these are becoming bad quality. Okay, fine. Next, we can also check for the warping factor. Now, what is the meaning of a warping factor? Warping factor is nothing but it gives us the out of plane deviation for the elements. That means, let us say you have a quad element. Now, how do you check the warping factor? What we will do is, we will assume that there is a diagonal drawn in the quad element. So what happens, this becomes one triangular element and this becomes the other triangular element. And then we will draw two normals from the triangular elements, and whatever is the angular deviation is reported as the warping angle or the warping factor. Okay, so if they are perfectly, means if it is a complete flat element, then the normals will have 0 degrees. That means they are not deviating, they are exactly lying in the plane. But if there are some warping angles, then the warping angle will start increasing from 0 and it will start increasing. So suppose if you have some warping angles, let us say we have a quad element. Let us say this is perfectly lying inside the plane and there is no deviation, so the warping factor is 0. But in the same case, let us say this is the element, and then from here if we have some deviations, so here you will have some deviation, let us say 0.1, or let us say we have another element like this. So this is a perfect shape, but the element has distorted. Let us say the warping factor is 5. So this is nothing but the warping factor, where it shows us the out of plane deviation, how many planes are distorting outside. So in warping factor, can you see you have more number of elements towards 0. That means, can you see, it is the worst value that we have is somewhere between 0.06 to 0.07, which is almost equal to 0. That means we are having all the elements as almost good quality elements. Next, we can also check for aspect ratio. Aspect ratio is the ratio of the longer side to the shorter side of the element. An aspect ratio of 1 is good. We can, in industry, you can see that they will generally allow aspect ratio up to 5, but anything above 5 we will consider to be very, very bad. Okay, so for understanding aspect ratio, you can say that aspect ratio is, it is the ratio of the longest side to the shortest side. So you can measure the aspect ratio for triangulars, for quads. Okay, now here you can see, if you're checking the aspect ratio, we have somewhere up till 1 we have, then we also have some aspect ratios near 2, above 2, but these, we also have some elements over here which are, see, look at these shapes. Okay, so this is having an aspect ratio of 4. That means they are distorting and the shape is getting distorted and they are very close to becoming bad quality elements. Then you also have something called as skewness. Now skewness is actually a very important check, quality check in the element quality, and skewness measures how close the element is to its ideal shape. That means if you consider a triangular element, the ideal shape will be an equilateral triangle. So a perfectly equilateral triangle, that means the skewness will be, if it is a perfect equilateral triangle, that means the skewness is 0. But as the shape distorts and the skew increases, this is a highly skewed triangular element. Similarly, if you have a perfect cube, that means it is a perfect quad, and here the skewness will be 0. But here, as the shape distorts, this is a highly skewed quad element. Now in skewness, if the value is 1, of skew is 1, that means it has degenerated, it has completely distorted, that element is degenerated, means it has not created that element. If the value of skew is from 0.9 to somewhere below 1, then you can say that they are bad elements. Okay, they are bad elements, the elements have distorted and they have become bad. If the value is from 0.75 to 0.9, you can say that they are poor elements. The quality of the elements is poor. If the skewness is from 0.5 to 0.75, we can say that these element qualities are fair enough. If not good, they are fair. If the skewness is from 0.25 to 0.5, you can say that these are good elements or good quality elements. Okay, and if the skewness is from 0 to 0.25, these will be excellent elements. The quality of these elements is excellent. And if you get any skew which is at 0, this is a perfect shape. That means it would be an equilateral triangle or it will be a quad. If you compare it in 3D, it will be a equilateral triangle, a wedge shaped like this, or a hexahedral element, a perfect cube. That means the skew is 0. So in our case, if you check the skew, we have almost the values closer to 0. So our range is between 0 to 0.67. So according to that, anything below 7.5 is we have fair and good quality elements. Okay. So this is how you can check the quality of your elements and understand whether the elements that you have generated are good or not. Now in this check, we have understood in Jacobian ratio that we have some elements that are bad. In element quality also we have understood that we have some elements which are closer to 0. Okay, so for improving these quality, what we can do is, now here if you see, we have got all hexahedral elements, but the size is not uniform. The element size is not uniform. So what we can do is, we can give, now currently the element size, we are not sure of the element size. It is a default size that it is taking according to the geometry. But if you want to wish to give the element size, you can give a definite element size to the elements. So what we will do is, let us say I want to give an element size of 3 mm. Now look at the sphere along with your cursor, it shows the element size. I will say I want it as 5. Okay, and then we will say update the mesh. Now what happens is, the entire mesh will come as 5. It will try to achieve element size of 5. Can you see over here? You can also go for 3 so that it becomes much more finer. Now look at this mesh. It has become fine. Let us go and check the element quality. Now previously we were getting lots of elements which were closer to, now see the worst element over here is 0.5. You are getting more number of elements which are closer to 1. So from here you can understand that the quality of element has increased. But here you will see that there are two types of elements that have been generated. There is one more element shape that has been generated, which is wedge shape. Wedge shaped element is nothing but, it is like this. This is the wedge shaped element, means it is not tetrahedral, because tetrahedral will become something like this. So it is also one of the shape that can be achieved in meshing. So we have some wedge shaped elements over here. If you want to clearly see them, you can see them over. So these are the wedge shaped elements that have been generated. So from this you can understand that we have tried to improve the quality of the elements by giving a definite size of 3 mm to the meshing. So here we have understood how to change the element sizes. Now the element size you have given over here has been applied to all the bodies. That means all the 3 bodies over here. So now we have understood how to create the hexahedral elements by editing the geometry. We have also understood how to check the quality of elements. And the next one more topic that we've understood over here is how to change the element sizing. So in the coming topics, we will then discuss about some more techniques that will be used for geometry optimization and some other advanced topics in meshing.